Okay, everybody, here's our review lesson on reliability. I'm going to give you really talk about some of the same things that we talked about in class on Monday, and hopefully that will help you prepare for the test, okay? When you come on Monday, we're going to talk about validity. There are also three different kinds of validity, so you want to make sure that you have reliability clearly in your mind so that when we do validity, you're able to tackle that new topic, okay? So remember, there are three kinds of reliability that we discussed. There's actually more than that, but we are limiting to these three different kinds of reliability. Okay, we have stability reliability, alternate form, internal consistency. So we'll review stability reliability first. It's consistency over time. It has to do with when you take the test. It means you can take the same test multiple times. You would hope that your performance does not vary a lot. Okay, so we want to make sure that the timing of the test, when you take the test, should not be a factor. That's called stability reliability. Okay, if you remember, there's also another application of that. It's called classification consistency. So if I am trying to decide who qualifies for something, I'm going to test them perhaps more than once. You would have to pass the test more than once in order to get into, maybe this is a higher math class, or to qualify to compete in something, okay, or to qualify to show mastery so that you can earn some kind of certificate. Okay, stability reliability has to do with when you take the test. Is that a factor? Okay, it shouldn't be. Your scoring should be similar no matter whether you take the test in the morning or in the afternoon, or whether you take it on Monday or you take it on Friday. Okay, that's why it's also renamed test, retest. Okay, it's as if you could take the test more than one time. Just a reminder that when we figure the reliability, it's reported in coefficients. The goal is to be as close to 1 as possible, knowing that you're not going to hit 1. Okay, 1 is perfect, and we know there's error in measurements. We're not looking for a perfect 1. We're just looking for something obviously above like 0.5, which would only be a 50-50 chance. Okay, all right, and then just remembering that there's always a meaningful level of instability between students' performances on two different testing occasions. That's really another way of saying you're never going to get a perfect 1. Okay, how high does the reliability need to be? How high are the stakes? Okay, that'll come up on a future slide. All right, then second type, alternate forms reliability. This is when you have two forms of the same test. Okay, the same test, two different forms of the same test. So remember, that could be a standardized test when you have Form A, Form B, Form C, Form D, so that you can test one student multiple times. Or it also could be different forms of a math test. Okay, but the idea is it doesn't matter which form you take, we're assessing for the same thing. Okay, it's two forms of the same test. And again, it's reported with correlation coefficients. Okay, let's talk about internal consistency reliability. This is different. Okay, I'm not looking for the reliability of scores over time. I'm not looking for the reliability of scores between two different forms of the same test. Look at the first line. Internal consistency means I'm talking about one test. I want to know if all of the test items on one test, okay, if they are working together. That's what I want to know. And remember, we said, depending on the type of test, if it's what we would call a selected response, like true, false, or multiple choice, or if it's more like an essay test, you use different formulas to figure out the reliability depending on the type of test. okay? And then the more test items, the more reliable it's going to be. And remember, we said that's like tasting something. The more you taste it, the more sure you are of the ingredients, okay? All right, then a review of the standard error of measurement. Notice the bolded word. Now I'm talking about the consistency of an individual's performance, okay? So I want to know if the student would take the test 3 or 4 times, how much variability will there be in the scores? Okay, because remember, we have an observed score, that's the score you get on your test. And then we have a true score, that's the score that we don't know what it is. And then we have the error score. Okay, so we would give the same test to the same person multiple times. And then we would be able to find out how much they miss each time. That would help us know what the standard error of measurement is, okay? Of course, it's not very practical, right, to give the same test to one person multiple times. So that's why this formula that you can use a formula to help you determine the standard error of measurement, okay? Remember, it's the consistency of an individual's performance. It's not talking about the whole group who took the test, just one person, okay? When you figure that out, when you use that formula, you have to know 2 things. You have to know the standard deviation of test scores. Remember, that's how spread out the scores are. Remember on Monday when I gave you that example on the chalkboard and I made 2 lists of test scores, and one of them we had students scoring maybe as low as a 30 and other students scoring 100 and anywhere in between. And then the second list, if you remember, everybody scored pretty close to a 90, okay? So when everybody's scores tended to cluster together, there was a smaller standard deviation, okay? So you have to know that. You have to know how spread out the scores are, and then you would have to know a reliability coefficient. And that would help you figure out what the standard error of measurement is, okay? Why do we care? Well, one, we care because we have to know as a teacher that that actual observed score that a student gets on a test, there is some imprecision there. Okay, we don't want to fixate on that student received a 91% and there's no way it could be any other. No, we know there's error. Could be a little higher, could be a little lower. Okay, it also helps you understand that the more students' scores you find at a particular cut score, the more frequently there will be misclassifications. So that's why we actually want to be really careful about setting a cut score too high. That will end up with more errors, okay? All right, so let's just do a what if. If we were in class, we would do small groups, but we can't do small groups. So I'm just gonna kind of talk these through with you to help you understand. Let's read the first scenario over here. Sean earns a score of 89 in a proficiency test, and he needed a 90 to test out of a geometry course. So since he was so close, okay, remember when you have students score really close to a cut score, you know, there could be some error. And since it was so close, he got to take the test again. This time, though, he only scored an 85. Well, of course, you can imagine everybody's disappointed. And his parents are like, how can that be fair if his score actually got worse? So the question is, what would you say to those parents? I think that you would tell them that you would explain the standard error of measurement, knowing that, sorry, because he got that 89, that doesn't mean that his score was exactly an 89. There's probably some error. Maybe, excuse me, I'm really sorry. Maybe the first time around he got, you know, his true score was really an 87. Actually, it could have been a 91. It depends on how much error was in there and which way it went. But since he took the test again and he scored lower, Actually, that means that the score could be, maybe if there was a 2 points of error, it could be an 83 or an 87. In any case, he's failed the test twice, and he probably needs to take that test again, or take the course. He probably is not going to qualify. Now, hopefully, if you have a score that you're, determining whether a student can test out of something, you have some kind of reliability measures on it, so you know how much you can trust it. Okay, but that would be a time to help students or help parents understand, and Sean too, that 89 is not a, we cannot guarantee that you got an 89 on that test, even the first time. Okay, all right, let's talk about the high school scenario on the next one. We have several teachers, they're using several forms of chapter tests in the classroom to prevent cheating. So, when you look at the tests, each student's test will look just a little different. And the students and their parents are worried that this is fair. What if I would do better if I had this form of the test? And a colleague explains the situation by talking about internal consistency reliability. Hopefully when I read that, red flag came to your mind and you're going, what? Internal consistency? Because that's not an example of internal consistency. Okay, you have multiple forms of a test. That's alternate form. If you have internal consistency, you only have one test, and you're talking about how the items on that one test function together. Okay, so just a reminder that we have 3 different kinds of reliability we've talked about. They are not interchangeable. So when somebody wants reliability evidence, the first thing you have to do is say, what kind of reliability evidence are we seeking? And also a reminder here that when you take your test, you're going to have to be able to explain in your own words the different kinds of reliability. In other words, define them. And if you remember, I suggested that even though, I said you should explain it in your own words, meaning you don't have to give the exact words in the textbook, but I'm highly recommending that you study the definitions in that chart in your textbook so that you can explain it without error on the test. In fact, I would memorize them. All right, here's another question for you to think about. Why do you think that although reliability is such a central concept in the appraisal of educational assessment devices, your text author recommends classroom teachers generally not mess around with the determination of reliability of the tests they personally develop? You might say, yeah, that doesn't seem quite right. If it's so important, how come I don't have to do it? Well, there's several reasons actually. So again, we don't have time, we don't have our class to discuss this in, so I'm gonna give you some talking points and maybe I can review this with you when we get to class again on Monday. One of the biggest reasons is time. Who has time to give their test multiple times? Another consideration is that the tests that you give aren't really high stakes. And you might say, well, what do you mean by that? Well, if you're giving a chapter test like the one you're going to take in a minute, so if you would happen to fail that, perhaps you would have opportunity to retake a test, or you have multiple chapter tests in the class, so you're not going to fail the class if you fail one chapter test. So I'm not suggesting you fail it, right? But just saying that you're not going to fail the class, or you're not going to, get kicked out of your program or something like that. It's not high stakes. You can also discuss it with the teacher. So if there was something that was inconsistent, maybe the way the questions were worded or something, you could discuss that with the teacher, and the teacher has local control over the grade. So maybe there was a problem with the way that you interpreted a question, and the teacher looked back and said, you're right, that was misleading, and I can tell that you understand it. I can give you the points, okay? They can go in and change the grade. It wasn't scored at a assessment agency or something. Also, hopefully you have given the tests, more than once, and you've had an opportunity to refine the questions, so you're pretty sure that the questions are usable and will help you know whether the student is proficient in that content or not. All right, let's talk for a few minutes then about, since we're not going to do reliability testing on your classroom tests, let's talk about just some practical tips for increasing reliability of classroom assessment, okay? And if you notice, this information is not from your textbook. It's from another book that I'm familiar with. It's called Educational Assessment of Students. It's by Brookhart and Nitka. Okay, so here are some just practical tips for you. Number one, maintain a classroom environment that encourages students to perform at their best. So we want to know what students know or can do. We don't want to represent their resistance or their lack of attention or motivation. So for instance, you're going to keep a positive classroom environment. You're not going to make anything real hard or real easy, and you're not going to put some gotcha questions on there. Sorry, my computer keeps sliding. Some gotcha questions that will make, I didn't think they were listening very well, and just to show them that they have to listen well in class, I'm going to ask that question. No, don't do that, okay? Your classroom environment is important, and you want to maintain one that encourages students to perform at their best. Okay, and I mentioned this a little bit before, but you want to match assessment difficulty to students' ability levels. Kind of going along with the idea of a ZPD, you don't want it to be too easy and don't want it to be too hard. Have enough questions for the consistency to show itself. Enough questions to show mastery, not so many questions that there's not enough time to do the test, however. Okay, but enough questions to show mastery. Of course, there's going to be a different, quizzes are different than unit tests, which are different maybe than final exams, okay? But what we're saying is ask enough questions that you can accurately tell what students know. Essays, papers, and projects should be scored with rubrics. We mentioned that just briefly in class, but that, and remember we said that the rubrics have to have enough information on them that you can actually, two different people could come to the same conclusion, okay? So clear directions. The rationale behind that is if a student does something very different, it's hard to score accurately. So you want clear directions so everybody's headed down the right path. You want systematic scoring procedures, clear rubrics or scoring guides. And then you want to score work without looking at the students' names. That will help you be more consistent, okay? Score answers to the same question for everyone, as opposed to scoring answers to multiple questions for one student. So what do I mean by that? Let's say that you have a discussion question. Well, let's say that you have 3 or 4 discussion questions on a test. So I'm not going to grade all of one student's test and then go to the next student and grade their entire test. What I'm going to do is I'm going to score every student's answer to discussion question number 1. And then I'm going to start over again. Every student's answer to discussion question number 2. And that will help me be more consistent if I'm looking at everybody's answer to the same question at the same time. Now remember these because we're going to talk about later on writing good essay questions, and this information will be repeated because this is how you become a good grader for your assessment, for your essay questions as well. Okay, and then if possible, especially if it's something, like think about a major project or a science fair program that you have at your school. Every student did a science fair, and maybe there's a essay contest, short story contest or something. Using multiple graders is a great idea. Okay, let's talk about grades. Here's the key question. Would I make the same grading decision about the student again? So, what I've done sometimes if, like for instance, if I'm grading a paper that a student has written or some other kind of project that's not just a straightforward true false or something, I grade it, and if I'm just a little unsure, like, not quite sure how many points to assign or something, I'll actually set it aside and regrade the paper the next day to make sure that I would come to the same conclusion. Okay, you want to not regret your decision, and that means that you want to grade too hard or too easy. Okay, and then using a sufficient number of different procedures to assess all the important aspects of the learning objectives. So we want to really be careful about, maybe you could say, putting all our eggs in one basket. Okay, so in other words, make sure that, for instance, if you're assigning a letter grade on a report card, then you would want to have some quizzes, some tests, maybe some um, performance activities, where it's not just a paper test that students do, maybe some observations, a sufficient number of different procedures to assess all the important aspects of the learning objectives. Okay, you don't want your assessment to just rest on one test. Okay, that's the end of the PowerPoint. That's the end of your review. Your test is going to be it'll be 5 multiple choice questions where I'll give you a description and you have to tell me what kind of reliability evidence is needed. You will have to write out the definitions for the 3 kinds of reliability. And then next you have 3 true and false statements related to this content. All right, hope you do well. I'll see you in class on Monday. Stay warm.